Alright, 18 is pretty straightforward. You got a planet, super flat, tall building, 1 mile tall. Turns out, by the way, according to Google, can't trust the Google, 1 mile, or can you? 1 mile equals 1609.3 meters. Read something the other day about Google implementing some sort of mechanism that will compare a bunch of sites to see if the same information is on a bunch of sites. And maybe if that's the case, then it's probably more legitimate of a search result, and push those results up to the top of the search queue. I'm not sure. Sounds interesting. Anyway, so we're trying to find the change in weight, which is really mg final minus mg initial, but they have the same, the mass doesn't change. What changes is the acceleration due to gravity. Let's say this is Earth. On the surface, it would be roughly 9.8. A mile up, it would be a little less than 9.8. We can actually, they gave us the weight at the surface. Weight equals mg at the surface, we'll call it gi, equals 600. And so mass, solve that for mass, equals 600 over gi. We could stick that here. 600 over, let's just call gi 9.8 just for the fun of it. Yeah. You know, interesting. When I first solved this problem, I didn't call this 9.8. I did some crazy stuff, which I'll show you. But I'm curious now. Maybe I'll pause it if I continue to be curious and see if it works by just calling this 9.8. But anyway, what I did before was, well, we know that Newton's second law, ma, is the net force, and the only force acting on you is Fg. And so, and when that is the case, we call the acceleration here the acceleration due to gravity, so really just mg. That equals g m for the planet over d squared. And so the m's cancel, and basically g becomes big G mass of the planet over d squared. So that's what I did. I just replaced these with this. So this becomes g mass of the Earth over, and finally you're up a mile. So this is radius of the Earth plus 1 mile. I'll change that to this later when I have more room, squared, minus gm over radius of the Earth squared. So we can rewrite that as, let me just divide this out so it's not screwing with your mind. Delta work is 600. Now they have gm in common, so I'm going to pull that right out. In fact, I'm going to replace it with the number 6.673 e to the negative 11 times mass of the Earth, e is 5.98 is friggin' Schmiegel. E to the 24 over 9.8. So got all that, and then this becomes 1 over radius of the Earth is 6.3 6.37 e to the 6 meters plus this many meters in a mile plus 1609.3. So that is all, and we're going to square all this. Squared. So that's all this minus 1 over 6.37 e to the 6. So it's just the radius of the Earth. Don't forget to square that. Holy cow. Yeah, that would work. This times this divided by this squared is 9.8. So I could have just called this 9.8, but yeah, whatever. Anyway, solve for that, and you get negative 0.304 newtons. So your weight drops by this much. So you become like 596 point something 6 or something. Yeah, so a little bit slightly less than 600. So not too shabby of a problem, but this concept is important. That's the acceleration due to gravity. That was this guy here, and I proved that to you in the notes. And that's probably pretty much it. Oh, well, altitude, like you're in an altitude of 1 mile. So remember, altitude, the distance is the radius of the Earth plus your altitude. That's your total distance. But yeah, alright, bye-bye.